All right, let's open question 1. Quick check. Which AWS service allows you to generate speech from text using pre-trained models? Select one answer. Review the answer choices on screen. The correct answer is option D. Polly is the purpose-built text-to-speech service. Amazon Polly converts text into lifelike speech using pre-trained models with various voices and languages. SageMaker is for general ML, Bedrock is for foundation models, and Lex is for chatbots. Hey guys, it's Stack Lessons here. Welcome to another practice exam. Today we've got 10 questions for you, covering ML lifecycle phases, AWS AI service selection, and inference latency. 6-second countdown after each one, so you can pick your answer, then the reveal. Pause whenever you need to. Good luck and enjoy. Keep score as you go. I will ask for your total at the end. Okay, question 2. Every phrase counts. Which of the following is not a method for fine-tuning foundation models? Select one answer. Review the answer choices on screen. The correct answer is option C. The not makes pre-training the odd one out here. Pre-training is the initial step in building a foundation model, not a fine-tuning method. Fine-tuning happens after pre-training to adapt the model for specific tasks or domains. Okay, let's handle question 3. The company needs to clean and transform data for machine learning models using a visual interface. Which Amazon SageMaker feature should they use? Select one answer. Review the answer choices on screen. The correct answer is option B. Visual interface plus no-code data prep. One service wins. Amazon SageMaker Data Wrangler provides a visual interface for data preparation and transformation, simplifying the process without requiring extensive coding expertise. Here we go, question 4. Convert the story into selection criteria. A technology company needs to translate patents from English to French, including embedded images like technical diagrams. Which type of machine learning model is most appropriate for this use case? Select one answer. Review the answer choices on screen. The correct answer is option A. Images embedded alongside text signals a multimodal requirement. Translation tasks involving embedded images and text require the capabilities of generative AI models, especially those with multimodal functionalities that can process both text and visual elements simultaneously. Next up, question 5. The trap is in the setup. A government agency is implementing Amazon Bedrock for an AI application within a secure VPC. Due to regulatory compliance, the VPC cannot have any internet connectivity, which AWS capability enables the required private access. Select one answer. Review the answer choices on screen. The correct answer is option B. 3 distractors all route traffic through the public internet. AWS PrivateLink provides secure, private connectivity between VPCs and AWS services without internet exposure, meeting the regulatory requirement for no internet access while enabling Bedrock functionality. Amazon Macy discovers sensitive data, but doesn't provide network connectivity. CloudFront is a content delivery network requiring internet access. Internet Gateway explicitly enables internet connectivity, violating the compliance requirement. PrivateLink ensures the necessary private connectivity while maintaining strict security and compliance standards. Service name keywords locked 3 answers fast. Not reverse the fine-tuning question. PrivateLink was the only option without internet exposure. Now, question 6. Picture the scenario first. Predictive Health Corp is in the process of creating an ML system to forecast potential disease outbreaks. They are currently inputting extensive historical health records into their chosen learning algorithm, enabling it to discern patterns and correlations within the data. What is this critical phase of the ML development lifecycle known as? Select one answer. Review the answer choices on screen. The correct answer is option A. Feeding data so an algorithm learns patterns, that is training. Training is the fundamental phase in machine learning where an algorithm is fed with data, historical data in this case, to learn patterns, relationships, and essentially tune its internal parameters. The output of this phase is a trained model. Now, question 7. This is a distractor check. Which factors can directly influence the latency of a machine learning model's inference performance? Select two answers. Review the answer choices on screen. The correct answers are option C and option D. Batch size and architecture feel primary, but they are secondary here. Two key factors directly affect inference latency. 1. Length of input sequence. Longer inputs require more processing time. 2. Length of output sequence. Generating longer outputs increases computation time. Batch size, model architecture complexity, and inference parameters have secondary effects on real-time inference latency. Let us keep moving. Question 8. The wording is the clue. Global Solutions Corp is engineering a system designed to execute tasks that traditionally require human intellect, such as advanced image analysis and strategic decision-making. Specific modules within this system autonomously enhance their task performance by processing extensive data sets. Which term best encapsulates the most comprehensive category for this entire initiative? Select one answer. Review the answer choices on screen. The correct answer is option B. Most comprehensive, that word locks in the AI hierarchy. Artificial intelligence, AI, is the broadest concept, referring to the simulation of human intelligence in machines designed to think and learn. Machine learning is a method to achieve AI, and deep learning is a technique within ML. Data analytics is a related field but focuses more on deriving insights from data rather than building intelligent agents. Let's slow down here. This is really about knowing which term is the biggest umbrella. Think of these terms as Russian nesting dolls. The outer shell is artificial intelligence, anything a machine does that mimics human thinking. Inside that sits machine learning, where a system learns patterns from data. Deepest inside is deep learning, which uses layered neural networks. Data analytics sits off to the side. It finds insights, but doesn't build thinking agents. Say your system has 50 modules. Some recognize images, some make decisions, some learn from data. Only one term is big enough to cover all of that. That's why AI wins. It's the broadest umbrella. Let us keep moving. Question 9. Use elimination aggressively. A financial services company needs to analyze customer feedback from survey responses to understand the overall sentiment. The solution must automatically detect positive, negative, or neutral sentiments in the text data. What are the most suitable AWS services for this solution? Select two answers. Review the answer choices on screen. The correct answers are option B and option E. Comprehend is obvious. The second pick is where candidates split. Amazon Comprehend and Amazon Bedrock are ideal for sentiment analysis. Comprehend specializes in NLP tasks, including sentiment detection, while Bedrock provides foundation models capable of sentiment analysis. Textract extracts text from documents, Translate converts between languages, and Poly converts text to speech. This question looks simple, but 3 of these services sound more AI-ish than they are. Let's break it down. Imagine you run a call center and you get 50,000 survey responses after a product launch. You need to know fast. Are customers happy or angry? That's exactly what Amazon Comprehend was built for. It reads text and returns a sentiment, positive, negative, neutral, or mixed, plus a confidence score. No machine learning expertise needed. Amazon Bedrock is also correct here. Its large language models can analyze sentiment too, especially when you need more nuanced reasoning. The three distractors, Tixtract, Translate, and Poly, pull text from documents, switch languages, and speak text aloud. None of them understand feelings. The exam rewards knowing Comprehend is purpose-built, and Bedrock is a valid LLM-powered alternative. Time for another one. Question 10. Identify the business need first. A fintech startup is developing advanced tools to forecast stock market patterns. The system analyzes extensive historical trading data to predict future price movements. What accurately describes neural networks in this financial application? Select one answer. Review the answer choices on screen. The correct answer is option D. Neural networks equal brain-like pattern recognition. Find that phrase. Neural networks in this context are deep learning models that simulate human brain pattern recognition capabilities, making them ideal for analyzing complex historical financial data to predict future trends. They excel at learning non-linear relationships in data, unlike simple linear regression. Neural networks don't function as database systems. They process and analyze data rather than store it. While they use optimization internally, they are primarily learning and prediction models, not optimization algorithms themselves. The brain-like pattern recognition capability makes them particularly suitable for complex financial forecasting tasks. This one's a definition question, but the traps are clever. Let's break down what each phrase is actually doing. Picture three coworkers all claiming to be the plumber. One sweeps floors, one tightens bolts, one lays pipes. That's what's happening here. Three wrong options use real-sounding tech words to misdescribe neural networks. The phrase accurately describes is your alarm bell. The other three each hold a partial truth. Databases store data, neural networks don't do that. Optimization is something that runs inside neural networks, but it's not what they are. Linear regression can't capture nonlinear swings in a stock chart with 50,000 rows of history. Neural networks are pattern learning models that mimic how the brain spots structure in messy, complex data. The exam rewards knowing that definition, not getting sidetracked by partial truths. 3 takeaways from this session. First, PrivateLink is the only way to reach Bedrock from a VPC with zero internet exposure. Second, inference latency scales with input and output token length. Batch size affects throughput, not latency. Third, pre-training builds the foundation model. Fine-tuning adapts it. They are never interchangeable phases. The hierarchy question, the inference latency multi-select, and the sentiment analysis pick are the 3 patterns that cost real points on exam day. If any of those surprised you, replay those timestamps. That's exactly where your prep time should go. Before you go, 3 quick things. If these sets help your prep, subscribing is the free way to keep them coming and to put them in front of more people studying the same exam. Drop your score in the comments. I read every one. If there's a different certification you want me to cover next, just name it below. That's how I decide what to build. And if anything about the pacing or the style could be better, tell me. I genuinely use that feedback.